This is a worked solution to the first question in exercises 5.8 of the EGM90 course. In this set of homework exercises, there are 4 questions for you to do. This should be fairly simple. Question 1. Question 2 involves you sketching some flow solutions. Question 3 involves you having a little think about how the Knudsen number of a flow changes as a space vehicle re-enters Earth's atmosphere. And question 4, which I'm also providing a video solution to. If I scroll down, which is part of a past exam paper question, by the way, asks you to compute this result for the mean molecular speed. So question 1 asks, given that the 1D, okay, so we're simplifying this distribution function, this probability distribution function of molecular velocity, down from typically what you a 3D distribution function for a 3-dimensional velocity, into 1D. N, remember when it appears in this context, represents the number density of molecules. So we've got this function NF of u is equal to a squared minus u squared for u between minus a and plus a. And outside of that region, NF of u is equal to 0. And it says compute the bulk density and the bulk velocity. Okay. Okay, so this is exercises 5.8, question 1. And this 1D distribution function, so we've got the function for n times f is a squared minus u squared for u between minus a and plus a, else the distribution function multiplied by n, the number density, is equal to 0. So let's just have a little think about what that distribution function actually looks like, because that might give us some clue about the expected result. So this is NF of u, this is u. So we know that when u is equal to 0, NF of u is a squared. We know outside of this range, minus a to plus a, NF of u is 0. So u squared would look something like this. It would be a curve sweeping up like this. So if we've got a squared minus u squared, we're going to have a function that looks something like this, and it'll be symmetric. Whoop, really badly drawn. Symmetric either side of the y-axis. Okay. Now this is straightforward. If we remember, there's a result that tells us how to compute mean quantities, and the mean value of Nm, the number density times the molecular mass, gives us density. So we just plug into that formula, density rho is equal to the integral from minus infinity to plus infinity. So over all possible speeds, n m f du. Now straight away we know that outside of the range minus a to plus a, nf is 0. So we can immediately change the limits on this integral from minus a to plus a. We'll pop in that nf is equal to a squared minus u squared. So we're left with m a squared minus u squared du, and then it's just a simple integral to perform. Let's rearrange this first to make this really clear what we're doing. Ma squared minus mu squared du. which when integrated gives us ma squared u minus mu cubed over 3 between minus a and plus a, which equals m this is going to give us ma cubed minus m a cubed over 3 minus, be careful with the signs here, minus ma cubed plus m a cubed over 3 and when we sum all of that up, what do we get? We're left with 4 ma cubed over 3. Okay, so we have a finite density. Now, you might already be able to spot what we're going to get for the bulk velocity of the fluid just by looking at the shape of the distribution curve. But let's work it out. So the bulk velocity, let's call the bulk velocity capital U. Now this is going to be the integral from minus infinity to plus infinity. Now remember, it's the average of all the molecular speeds. So the quantity we're averaging is just U multiplied by the distribution function, integrated all over the whole or all possible ranges of values of U. So this is going to be the integral from minus infinity to plus infinity. Remember, we've got nf, so this is going to be u times nf of u all over n du. Now the number density is just a value, it's just a constant value, so we can bring 1 over n outside. We'll substitute in the form of nf into this equation, and we know that it only goes from minus a to plus a. So this becomes u, and it was a squared minus u squared, wasn't it? A squared minus u squared du, 1 over n times, so we're going to get u squared a squared over 2 minus the u times u squared becomes a u cubed, so this becomes minus u to the 4 over 4 between minus a and plus a, which equals a to the 4 over 2 minus a to the 4 over 4 minus a to the 4 over 2 plus a to the 4 over 4, and obviously that cancels with that, that cancels with that, and we're left with 0, which some of you might have guessed is what we were going to get, because of course the distribution function is symmetric about the y-axis where u is 0, so there's an equal probability of molecules moving, I guess, in the right-hand direction compared to the left-hand direction. So the net effect of some molecules on average, or half the molecules on average moving to the right, half the molecules on average moving to the left, means that the net effect cancels out, and we end up with 0 velocity. So that's quite a straightforward one.